Welcome to our Business Intelligence series. This time we are going to look into kNearestNeighbors task. This is Pulau Jumia in Terengganu, just 800 kilometers from Pulau Kapas, just a small island. Right, back into the topic. We'll introduce what is kNearestNeighbors and how kNearestNeighbors works, and we'll look into examples and then we summarize our series. First, we look into clustering. A cluster is a collection of data objects where we put similar objects in one cluster and dissimilar objects in another cluster. So when we do cluster analysis, we are actually finding similarities between objects or data points, and we group them or cluster them in one group. Basically, clustering is an unsupervised learning task where there is no predefined classes. Examples of clustering would be to segment customer based on their buying patterns. We can also group houses in a town into neighborhoods based on similar features. It can be the size of the house, the price of the house. We can also do clustering to identify new plant species, or we can identify similar web usage patterns using clustering. Basically, we have looked into hierarchical and partitional clustering, where we have talked about a dendrogram as an example of hierarchical, and we also have talked about k-means as an example of partitional clustering. Now we are going to look into kNearestNeighbors with a question mark. Why? We are going to discuss whether kNearestNeighbor is a clustering or otherwise. In the kNearestNeighbors algorithm, items are iteratively merged into existing clusters that are closest. It is an incremental process, and there is a threshold T used to determine if items are added to existing clusters or new clusters is created. So, in short, kNearestNeighbors is actually to classify a new object based on the attributes and training samples. Wait a second. We are talking about training samples. Okay. So whenever there is a training sample or training set, it must be supervised learning. So whenever there is a supervised learning, it is not clustering. It is classification. So kNearestNeighbor in our case is actually a classifier, but we cover this because it is uses the same parameter k as k-means. So k-means kNearestNeighbors. Okay, so we are covering this kNearestNeighbors task into clustering task. These are the algorithms. Those who are interested to do programming, they can follow this algorithm. Now let's look at some examples of kNearestNeighbor. This is the first example. We have several data points with the coordinate 7, 7, which is classified as bad. 7, 4 as bad. These are the 7, 4, 7, 7. And we have 3, 4 as good and 1, 4 as good. So we were given a new data point, which is at coordinate 3, 7, the green one here. And we were given k, or the number of neighbors, 3. And what we are supposed to find, what will be the classification of the new data point. So first of all, in kNearestNeighbor, we need to find the distance or the squared distance between the new data and existing data. So we have these are the existing data, and we want to find the distance between this new point, which is 37, and each of these existing data points. So for example, the, the, the distance between 37 and 77 is basically 3 minus 7 squared plus 7 minus 7 squared. This is the squared distance. Okay, so you can always square this value, but I'm not going to square this. I'm going to use this squared distance. So we have 16, 25, 9, and 13. These are the distances between the new point to the existing data points. Then we need to rank the distance and select the k nearest neighbor. So these are the rank. The closest we rank number 1, followed by this point 14, number 3 is 77, and number 4 is 74. When we sort these points from the closest to the farthest, we use simple majority for the category as the prediction value. So from the 3 neighbors, k equals to 3, 2 are good and 1 is bad. So the outcome or the classification for this new data point 37 is good. So if we were to look into this as clusters, so these are the clusters, because the green one is our new point. So out of these 3 neighbors, 2 are good and 1 is bad. So the classification for the new data set is good based on the 3 neighbors. Okay. Please keep in mind, what if the value of k changes from 3 to 4? Okay. We'll cover that later on in other examples. Now in second example, this is a very classic data set. We have the by computer data set. We have the attributes for age, income, students, and credit rating. And we were given the new tuple, which is age less than or equals to 30, income is medium, student is yes, and credit rating is fair. Now it asks us to use similarity, okay, and the value of k is given as 5. We cannot find distance. Okay, how to find distance? We need to use similarity. Okay, so find the similarity between the new data and existing data. So this is our existing data. Okay, the blue ones, and the new data is this one, in the orange background. So how do we find similarity? We just compare for the first one, for example, is this value less than or equals to 30 same with the first tuple less than or equals to 30? If it is the same, then it is similar. So if this value is similar, we put value 1. If the value for the attribute is not similar or dissimilar, we put 0. Okay, so for the first tuple is 1 0 0 1, and we take a summation of the values of this row. 1 plus 0 plus 0 plus 1 is going to be, which is going to be 2. Okay, these are the labels. There is the same label with this one here. So we do the same thing for each of the tuples, and we have the summation of the similarities. In this time, the higher the number, the more similar the data. Okay. So we have these values of 2, 1s, and 3s. Next, we want to rank the distance or the similarities actually, and select the k nearest neighbors. Okay, so we rank. Okay, we just ignore the values of this data set. Okay, we rank these similarities values from the highest to the lowest. We have number of 3s and 2s and 1s. So if you use k equals to 5, then we have 4, okay, 3 yeses and 2 nos. Okay, so based on this k equals to 5, the outcome or the possible class label for this new tuple is yes. Okay, so the class tuple is yes. Now the last example, example number 3, similar to the previous example where this is also a classic data set, which is the play tennis. We have the attributes outlook, temperature, humidity, and wind. And we were given a new tuple, which is sunny, cool, high, and wind is equals to strong. And we want to find whether, given this condition, okay, this outlook, temperature, humidity, and wind, is that person going to play tennis or not? So similarly, the first step is to find the similarity between the new data and existing data. Those values of attribute is going to be labeled as 1 if it is similar. So sunny and sunny is similar, so we put 1. Those who are dissimilar is we're going to label it as 0. And we're going to sum, again, the sum of the rows. So 1 plus 0 plus 1 plus 0 is going to be 2. I think the highest is 3 here. Okay, so the higher the number, the more similar the tuple to the existing data. And these are the rank the distance or the similarity and select the k nearest neighbors. Okay, so if you rank from the highest to the lowest, we have k equals 5. If k equals to 5, we have 1, 2, 3, 4, 5. Then out of these 5, there are 4 no's and only 1 yes. So if k equals to 5, then that person is not going to play tennis. However, what is the outcome or the class label if k equals to 8? So 8 is 1, 2, 3, 4, 5, 6, 7, 8. We have 4 yeses, and 4 no's. So it is a balance between yes and no. So if we are faced with this situation, we should change the value of k so that we don't have a stalemate. Okay? So select k value so that the class label would point to a value, either yes or no. Okay, so because the value is going to be just a simple majority of the category as the prediction value. Okay, in summary, it is actually a classification task because it is supervised learning. It is covered here in the clustering section because of the k term. Okay, we have k-means and we have k nearest neighbors. Okay, so you need to differentiate. K-means is clustering and k nearest neighbor is classifier or classification. How does this k nearest neighbors work? Okay, assuming we have two clusters, we have cluster A and cluster B. A is with the green, A is with blue color, B is the green color, and we have a new point in between the clusters. So what we should have done is to calculate the distances between this new point and all the data points. And based on the number of neighbors, we are going to find how many class labels that point to class A, how many class labels that point to class B. So in this case, we have 2 class B and 1 class A. We have k equals to 3 here. So the class label for the new tuple is going to be in class B. Okay. So we have looked into examples that uses distance and similarity. Okay, the distance we find distance which are uh, nearest, so the minimum distance. But if we use similarity, we use the value which is the higher. The higher the value, the more similar the new tuple to a preferred to the existing data. So in summary, uh, our k nearest neighbors is also known as kNN or small k dash nn. It is a supervised learning task which uses proximity, whether in terms of distance or similarity, to classify or predict about a grouping or clustering of a new data point, with the assumption that similar points can be found near to the point of interest. So if you have more points uh, pointing to a class label, then the new point would also point to the new class label. That's all for now. Thank you very much.